Okay, so in this question, I'm going to teach you how to model this diagram in SOLIDWORKS, so to relate to the sheet or that you've done in the drawn video that's related to this here. Right, so in SOLIDWORKS, we're going to go new and we're going to open up our planes of reference document. Okay, now, so we're immediately going to save our work. Alright, and then I'll put it into our relevant folder. So I'll just pause while I go through this. So that's that done, and that's what I called it. Now, in this lesson, alright, I'm going to show you how to make a cone using a loft. Okay, so the loft tool here. Okay, or sorry, a surface loft rather. There's many different ways, so a lofted surface is what I'm going to show you. So I'm going to click the horizontal plane here, Control and A to look through it, to it, sketch, circle, to draw this in here. I'm going to click OK, save my work. Smart, now I'm going to position the cone here to suit myself here. Now, so smart dimension, click the point here, and the point there, and we'll say 100 there for ourselves. No, well that's what you call it. In the last video I wasn't looking properly at that question. It said it should be 9. Alright, so the vertex of the circle should be 9 from the XY line. So the radius was 30, so this should be 39. Alright, and we're going to click this circle and we're going to type in 60 here. Right, now we're then going to click the point here and give it a dimension here. We'll say 100 from the origin, and now that circle has gone black. We're going to exit our sketch. We're going to hold down the rolly button of the mouse and move it up. We're going to add in a plane now here. To do a lofted boss base or a surface loft, you need two different profiles, so two different sketches, and they cannot be on the same plane. They can't be on the same level. So we're going to go to insert. Okay, where am I going? Sorry, features, reference geometry, sorry, plane. We're going to click this plane here, and it's 60, we're going up. So it's 60, we're going up there. So we're going to type in 60, and we're going to click OK. Now, you should rename that apex plane, cone A, base sketch. Okay, so I'm going to click the apex plane, sketch on it, point. So I'll just click anywhere there, click OK, Control 8 there to look at it, turn off the point tool. Okay, so I'm going to click that point, hold down Control, click that one, make coincident. Now it'll say fully defined. Save your work, and I'm going to view it in 3D. I'm going to go exit sketch, surface, lofted surface, click, I'll just clear that there, click the point here, and the base, and see the way we have a cone there. Alright, now, okay, cone A, cone A, apex. Now we have to get point P. Okay, so we're going to have to use a 3D sketch to locate this. Okay, so I'm going to click this plane here, Control 8. Okay, I'm going to go sketch, circle. Now, I'm going to start in the middle there. I know the point P is 30, alright, from one of the vertices. So I know it's 30 from that point there, so it's 60 from the center, and I know it's 15 down from the XY line. So So there's, I can now, or I can actually, there's no need for that line, I can delete that. So smart dimension, click this line and this one, type in 60, and then click this one and type in 15. And then click the line, make construction geometry, and you can exit your sketch. CS1, so that means construction sketch 1. Now I'm going to rotate it around, and I'm going to go drop down under sketch, 3D sketch. I'm going to select the line, so this is a 3-dimensional sketch. So now look, I want it to go along this red arrow there, so that's the y-axis. I'm going to click the line and say make along y-axis, so that is vertical at all times. I'm going to go smart dimension, and I'm going to go 33 here. Okay, now that, construction, right, that's where the apex, that's where point P will be. So that's where point P will be. Okay, now I'm going to turn off the sketch, so untick 3D sketch. I'm going to go insert a new plane, features, reference geometry plane. I'm going to click this point, and I'll show you a new way of creating a plane. I could click that plane there, but if I click a point and a line, the plane will always be perpendicular to the line and start at the end point. So there we go. And we can rename that Apex Plane 2. Right, now I'm going to click this face here, Control 8, sketch. Okay, this one here, circle. Okay, but as a matter of fact, I actually can't do circle in this because I don't know what size it's going to be, so I'm going to have to change it around. Okay, I don't really need that plane anymore, or well, I did need it. Alright, so what I'm going to do is I'm going to go features, reference geometry, plane, okay, this point here, and this line. I'm going to click OK. Now I'll just hide that for the time being. Okay, I'll hide the apex plane too, as it's in the way. Now we're going to click this plane, Control 8. Now I'm going to go line, so I'm going to draw a line there, and it has to be at the same angle as this one, so it has to be parallel. So I'm going to click that, hold down Control, click that one, say make parallel, and now you see the way it's gone black. Now I'm going to exit the sketch, surface, revolve surface, click this one here, and axis clear selection, sorry there. I need to right click, edit the sketch to get back in there, surface, revolve surface, axis of revolution is this one here, and click OK. And there's new plane done. I can right click, hide that plane tree. I'll add in some color here. Okay, cone B. Now, watch what we can do now. If we go features, reference geometry plane, first reference is cone A, second reference is cone B. Okay, and then it says fully defined, so click OK. And that's there, our plane. Alright, now to get our HT on the computer, alright, we can go sketch, intersection curve, so plane 4, and the portion of the horizontal plane, and click OK. There's our HT. And then to get our VT, we can click plane 4 and portion of the vertical plane, click OK. and then we can turn off our sketch now. So we can rename this traces and this tangent plane. But what I want to show you here is why did this little method work? Why did that work? Right, now the key principle is parallel lines are parallel in every orthographic view. Okay, so I'm going to click this here, Control 8. Right, and what I'm going to do is I'm going to click this tangent plane. Alright, so the tangent plane is selected and I'm going to go sketch. Right, so I'm going to go line, and I'm going to draw a line in there until it touches here. Okay, basically a portion of the vertical plane. I'm going to click this line, hold down Control, click that one and go make parallel. Now, what we're going to do is look at that in 3D. So this line is parallel to that one. And now in elevation, that line is parallel to the HT again. I'm going to exit the sketch here and now look at the projections of it. So if I go to the vertical plane and go sketch and convert entities, so click out there side, convert entities. See that, click that line there. See the way it's a horizontal line. And then if I exit the sketch and go down here to the horizontal plane and press sketch and go click out to the side there to unselect it and convert entities again, click OK, see the way you have it there. Now, so when the line hits what you call it the XY line in plan, its elevation is right there on the VT. So if I went to turn that off and went into a 3D sketch, there we go. So join them together in 3D. So to make sense of that for you, okay, when a line, okay, parallel to the HT, okay, hits the XY line, it's on the vertical trace in elevation, provided that the line you're drawing is on this tangent plane. So that line there, it hits the XY line in plan, so its point there is on the VT in elevation. Alright, and if you have 2 points, you can define lines. So we have that one, and we needed to get this one here. So if I draw a line parallel to the XY line in plan, or parallel to the HT rather in plan, and then from the point on the cone which we know is on the tangential plane, or the tangent plane, we go straight across, aka parallel to the HT in elevation. Where they intersect will give us a point on the VT. Alright, that's that video done.